Hey guys, Mr. Middleton here. Today we're going to talk about the distance and midpoint formula. At the end of this video you should be able to use the distance formula to find the length of a segment on the coordinate plane, and you should be able to use the midpoint formula to find the coordinates of the midpoint of a segment. Okay. In lesson 3 we found the length of the segment using segment addition postulate. But what happens if the segment is on a coordinate plane? Okay, so let's look at this first example. It says to find AB. It wants us to find the exact length and then round your answer to the nearest tenth if necessary. Okay. The segment addition postulate doesn't apply in this case because with our segment addition postulate, remember we only had like 1 point. They would tell us, hey, this is -3 and this is 2. And we could just find the length and say, okay, well that length is 5. Well, this is more than just a one-dimension direction, and so we'll have to do something a little bit more involved than just the difference between some coordinates. So in order to do that, we need to find a better way, and that better way is the distance formula. Okay, distance formula is this. Distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. And that might seem like a lot, but I'll show you how the distance formula is really Pythagorean theorem hiding. Pythagorean. Okay. It would be beneficial to understand this, but I'm not going to be testing you on whether you know how the distance formula is the Pythagorean theorem. Okay. So remember that Pythagorean's theorem went like this: a squared plus b squared equals c squared. Correct? Okay, well, we can do that same thing here, and actually you can even notice it in the diagram here. We're finding the difference of the x's and the difference of the y's. Okay, the difference of the x's, if we used our formula here, I'll just use the distance formula. Okay, the difference of the x's, if I said the x coordinates is -3 and 2, so if I said, okay, well I'm going to do 2 minus -3, since I'm subtracting a negative, I'll say plus square. Okay, and then I'll do the same thing for the y's. Okay, remember our equation was plus, and then my y's, I'll say 4. Alright, let me do the same direction. -3 minus 4 squared. Okay? Alright, so then what we had here was 2 plus 3 squared, or 5 squared, plus -3 minus 4, or -7 squared. You can have that here. And that will give me 25 plus 49, the square root of that, or we'll just say square root of 74. Okay, the square root of 74, that's what that would be. Okay, so this would be the exact length. Okay, square root of 74. Okay, now we did that using the distance formula. Okay, I'm going to show you how we can do that using Pythagorean's theorem. Okay, notice all we did really was we found the difference of the x's and the difference of the y's. And I can make this diagram just a right triangle. And I can say, okay, how far over till I get from one x to the other? 1, 2, 3, 4, 5. 5. Okay. How far until I get from one point to the other vertically? 1, 2, 3, 4, 5, 6, 7. 7. And so now I can use a squared plus b squared equals c squared, knowing that 5 squared plus 7 squared will equal that distance squared, which we don't know, but I'll just call it d. Okay, it's d squared. Okay, so really, these two lines are equivalent. Okay, they're the same thing. Okay, so the distance formula is really just Pythagorean's theorem. So if you are, especially if you're given a coordinate plane, you are able to draw that triangle out and do the same work. Okay. So if they ask us to write round to the nearest tenth, we can do that using a calculator. The square root of 74 gives us 8.6. Okay, so you've got two options there. You can use Pythagorean's theorem. You can also use the distance formula. I'll show you Pythagorean's theorem here without a coordinate plane. And all we're doing there, guys, is we're trying to find the difference between the x values, the difference between the y values, and then we can use Pythagorean's theorem. So the difference between the x's, -2 and -8, how far apart are those? Well, they're 6 apart. 6 squared. -2 minus -8 plus 8. Take the absolute value of that. Okay. We can do the same thing with the y's. Okay, the difference between the y's. And so we'll say how far apart is -1 and 7? Well, -1 minus 7, absolute value of that gives us -8, so absolute value of that will be 8. And then that will help us find the distance, or the length of RT. Okay. And so now we can just go through, plug in numbers, or evaluate this to get the numbers. I just plug them in. So 6 squared is 36. 8 squared is 64. And that should give us d squared, because that's Pythagorean's theorem, a squared plus b squared equals c squared. Alright, and so then we get 100 equals d squared. And so in order to find out what d is, we'll need to take the square root of 100, which hopefully everybody here knows is 10. Okay? We could say 10 and -10, but remember that distances can't be negative, so that negative root becomes unnecessary, at least for this moment in time. Okay. Alright, so that's using the distance formula and using Pythagorean's theorem in its place. Backside, the midpoint formula. It can be helpful to find the middle of something. Okay, so think of the midpoint as finding the middle of something. For example, if Billy got 60% on his first quiz and 90% on his second quiz, the middle, the middle, or average quiz score would be what? How would you find the average quiz score? Well, you'd find that because you say, well, his first one was 60 and his second one was 90, so we add those together. And since we have 2 quizzes, we take those 2 scores and divide it by 2. 60 plus 90 being 150. 150 divided by 2 is 75. So I know his average, or mid of his quizzes would be 75. Okay, percent. Okay, we do the same thing with segments on a coordinate plane. It's essentially finding the middle, or the average, of both coordinates. Okay, so the midpoint is, we'll take both coordinates, x1 plus x2, and divide it by 2, comma, do the same thing with the y's, y1 plus y2, and divide it by 2. Notice that the answer for finding the length is a number, while the answer, well, that's a terrible B, the answer for finding the midpoint is given as a coordinate. Okay, and just to refresh so that we know, it's always x comma y. Always has to be that way. Alright, so let's find the midpoint of this example here. They ask us, or they give us 2 points. I'm just going to name these 2 points just so I can reference them. Doesn't matter what you call them. Okay, so this is at -1, 2, 3, negative because it went left, and 1, 2, 3, -3 because it went down. So -3, -3, and this will be at point 2, up 1, 2, 3, 4, 5, 2, 5. Okay? And so it asks us to find the midpoint. I'll do that because I'll take the two x coordinates together. Say 2 plus negative 3, or minus 3, over 2. 2 minus 3 gives us 1 over 2. And I'm just going to leave this 1 over 2. I'll do 0.5 just so you guys can see I simplified. Okay, so the midpoint of my x's is 0.5. I can do the same thing over here with my y's. I'll do 5 plus negative 3, or minus 3, divided by 2. So that's 2 divided by 2, which is 1. Okay, so the midpoint of this segment then will be 0.5, comma 1. Okay, somewhere like 0.5. That doesn't look right. 2 minus 3. Oh, that's negative 1. Look at that. And that's why you check your work. 2 minus 3 is negative 1. If you guys said that to yourself and was screaming at the screen, gold star for you guys. It's invisible, but you got it. Alright, so there we go. That makes more sense. Negative 5, 1. Alright. See, I was checking my answer, like you should do, and I said, this doesn't make sense. The midpoint should always be on the line. Okay, and now it is. Alright, so that will be the midpoint. iCloud A. Alright, there we go. Alright, so here we go. Another example. In this example, we have QS, and they're asking us to find both the midpoint and then find the distance of QM. So we're going to find the midpoint. We'll take the x coordinates, 3 plus 7 over 2. We'll take the y coordinates, 5 minus 9 over 2. Okay, so 10 over 2, comma, negative 4 over 2, which will give us 5, comma, negative 2. That's the midpoint. Alright, and then they ask us to find QM, which is telling us to find the length of that. And so now I'm going to do the distance, or the difference of the x's. So how far apart is 3 from 7? 4. Okay, squared. How far apart is 5 from negative 9? Well, 5 minus negative 9 or plus 9, 14 squared. And so that equals c squared. Now I can do Pythagorean theorem. 16 plus, what is that, 196 equals c squared. Just double check to make sure I got my math facts down. Plus 16. So c squared will be 212. And I can find out what c is by taking the square root of 212. Let's do that, make sure that's over here. Square root of 212, which gives me 14.56. It tells me to round to the nearest tenth, so I'm going to say 14.6. Okay. Alright, now this final one is a little bit different. Okay. In this final question, instead of just giving us the instead of just giving us the points, the endpoints, what they did was they said, hey, the midpoint of Kane is 3, 4. So this point is the midpoint. It says one of the endpoints, K, has a coordinate of negative 3, 2. Find the coordinate of N. Kind of throws a wrench in just plugging it in and doing the same thing. We have to think a little bit. Okay, and this is how we're going to do it. We have the midpoint formula. Okay, but now we're changing where our unknown is. Okay, now previously we really didn't write an unknown here, but in these other equations, if you follow me back up here, we had 3 plus 7 over 2 equals x. We didn't know what it was going to equal. Okay, and here we have 5 minus 9 over 2 equals y. We didn't know what it was going to equal. But now we do know what that midpoint is going to equal. Okay, and we know the first coordinate. We just don't know the second. So how that changes our problem is, I know that I'm going to take my first coordinate, negative 3. I'm going to add it to an unknown. Let's call it x2 over 2 equals 3. Sorry, this is 2. Okay. And I'm going to do the same thing for my y's. I have this unknown -2, or sorry, that known, plus y2 over 2 equals 4. Okay, so really it's the same thing now, and now I just have to solve this for x1 and x2 and y2. Okay, so do that for me. Solve that. Tell me what that other point, the coordinate of n, is. Okay, and bring it to class. Complete it. See it.